Every single time you click your mouse, type a message, or stream a show, there's this tiny, incredibly powerful engine at the heart of your device, making it all happen. Today, we're going to take a journey right inside that engine, the central processing unit, the CPU. It's really the unsung hero of our entire digital world. So let's kick things off with a pretty basic question. When you tell your computer to do something, I mean anything at all, from opening a simple file to rendering a super complex video, what part of it is actually doing the heavy lifting? What's doing the thinking? Well, you guessed it, it's the CPU. The best way to think about it is as the computer's brain. It's the part that crunches all the numbers and executes all the instructions. It's basically the central hub that's directing traffic, telling the memory, the screen, and the keyboard exactly what to do and when. It's like the conductor of a huge digital orchestra. All right, let's get into the history here, because to really appreciate the tiny silicon brain that fits in your phone, you have to understand its ancestors. And trust me, they were absolute giants. See, way before microchips were even a thing, the idea of a processor was basically a room-sized collection of clanking electromechanical relays and glowing hot vacuum tubes. These weren't personal computers, not even close. They were these massive, industrial-scale calculating beasts. What's just wild about this timeline is how fast everything accelerated. I mean, we start in 1947 with a machine like the Mark II. By the 60s, you've got these huge corporate mainframes from IBM. And then bam, the real game changer in 1972, Intel's 8008. The entire processing unit goes from a room full of equipment to a single chip. That's an insane leap in just 25 years. And you have to understand, these early giants were a totally different animal. Programs weren't apps you could just download. They were instructions that were physically fed into the machine on paper tape. And these things were so complicated and so expensive that only governments and the biggest corporations could even dream of owning one. But, even way back then, you can see the seeds of modern computing, like the idea of parallel processing in Eichen's early machines. So the big question is, how did we get from a brain that filled a room to one that can sit on the tip of your finger? Well, the answer is what was probably the single most important moment in modern computing, the microprocessor revolution. And this quote just says it all, doesn't it? The magic ingredient was the integrated circuit. All of a sudden, all those complex, room-filling connections could be perfectly etched onto a tiny little piece of silicon. And that made powerful calculation available to basically everyone, in things like pocket calculators. And here you can really see that incredible shift. We went from the mainframe, this corporate behemoth, to the microcomputer, which was designed for individuals. This wasn't just a change in technology, it was a total social and economic revolution. For the very first time, computing power wasn't just for giant institutions anymore. It was becoming a tool for the rest of us. And this right here is the main takeaway. It's really simple. Without the invention of the microprocessor, there's no personal computer, no laptop, no smartphone, period. This single invention didn't just create a new gadget, it completely democratized information and unlocked the entire digital world that we all live in today. Okay, so we've got the brain, but a brain is pretty useless if it can't talk to the rest of the body, right? Well, in a computer, all that communication happens on something we can call the data superhighway. This highway is officially called the computer bus. It's basically the whole network of electrical pathways that connects the CPU to everything else, to the memory, the hard drive, your graphics card, you name it. It's how all the different parts talk to each other, and most importantly, back to the brain. And the speed of that highway is absolutely critical. Think about it. You could have the fastest, most powerful processor in the world, but if the bus is like a slow, single-lane country road, your whole system is going to feel sluggish. A wider, faster bus means more data can move at once, which is absolutely essential for a high-performance computer. And you can see that race for speed right here. In the mid-80s, the AT bus could move data at about 2 megabytes per second. Just a few years later, IBM's microchannel design boosted that all the way up to 20 megabytes per second. That's a tenfold increase. For the user, that meant way faster graphics, quicker file access, and just a much, much snappier experience all around. So we've made the brain super small and the highways super fast. So what was the next logical step? Well, if one brain is good, then having multiple brains working together has got to be even better, right? And that brings us to the modern era of multiprocessing. Now, to get this, we first need to understand something called threads. Imagine a program is one big project. A thread is just a single, specific task inside that bigger project. Modern software is really smart. It's designed to break its big project down into tons of these smaller threads. And this is where it all comes together. Remember that idea of multiple brains working together? That is exactly what a modern CPU does. It has multiple cores, which are basically individual little processors living on the same chip. Each one of those cores can work on a different thread at the exact same time. That's why you can have a video call going, a game open, and like 50 browser tabs all active at once without your computer just grinding to a halt. It's multi-core processing, making it all feel seamless. So let's just do a super quick recap of this whole journey. We started with calculators as big as a room. Then we shrunk that massive brain down onto a single tiny chip. After that, we built faster and faster data superhighways to connect everything. And finally, we started putting multiple brains or cores onto that same chip to let them all work in parallel. What an incredible evolution, right? From these massive, clunky machines to the multi-core powerhouses we all have today. Which kind of leaves us with one final big question. What's the next great leap going to be? Are we headed towards quantum computing? Or maybe processors that actually mimic the human brain? Or something else that nobody's even thought of yet? One thing's for sure, the journey of the CPU is far from over.